what I'm going to do is to briefly go over what are the technology that drive the different discipline of system biology. If you think about biology, you think about living organism, you're looking at the dynamic property in terms of, because that we define living organism as an organism that exchange energy and matter with the environment. So the dynamic balance of the output and the input at the expense of consumption of nutrient to maintain a homeostatic state is the phenotype of the cell. So if you want to look at living property of anything, you look at the balance of all these things that maintains homeostasis. So for us, the property of living organism is its phenotype and can be defined by balance of flux at steady state and by the dynamic of its metabolic response when the system is perturbed. These are measurements that we can provide with tracer-based metabolomics. So just to reiterate the differences between traditional biochemical molecular biology versus tracer-based metabolomics. So chemistry and molecular biology look at a collection of objects, reactions of substrate, whereas tracer-based metabolomics look at the network and the reaction of the network in response to substrate. So in the traditional chemistry, you don't define a system boundary. You look at individual reaction as if it exists by itself. And of course, in tracer-based metabolomics, we define the system boundary so we can define input and output. We can define the direction of flux. So here we talk about linear pathway. We have extreme pathways. So time consideration is not important when you study knockout of enzyme or increased expression. And the reason why it's not important is because you look at steady state. And of course, tracer-based metabolomics, you can look at steady state as well as dynamic state, which is probably more comprehensive. So I use this map, as you see, that is a map of LA, to just give you an analogy of the different system biology in terms of what you know in your daily life. So if you look at genomic, it's pretty much like describing the topography and the geography of the land. Proteomics describes the structures on the land and the cities. Metabolomics is like counting the number of cars or people in each town or city, but it doesn't tell the dynamics of what goes on. So reaction pathway are similarly to describe the direction of each road, whether it's north or south or east or west. Now, tracer-based metabolomics look at the flow of cars and people.